now what we can do is we can take this minus delta over to the left-hand side, and we get 4 delta plus delta must be greater than 1, right? Or 5 delta must be greater than 1, which implies that delta must be greater than the fifth. So as long as $1 today is worth at least 20 cents tomorrow, right? Or as long as like 5 likes today is worth 1 like tomorrow, then there's going to be cooperation, because player 2 is going to care enough about the future. Does that make sense? Let me just stop there for a moment and ask if there are any questions, because we went through a lot. Any questions? Okay, what are you confused about? No, ask the question.
I think I was just lost from the beginning,
But I don't really care, like, for what we do we need all of that? What we're gonna apply to all those steps?
What are you going to apply? Which steps? You mean these steps here?
All of them. What we're gonna do with them?
So imagine that you are, let me think about it. You play tennis, right? Okay. Let's say you and I are playing tennis. I play tennis as well, but you play much better than I do, right? And we decide that we're going to just call our own shots, right? Now, if the ball goes out, what should I call it? I should call it out if I'm an honest person, right? But if I want to win, how should I call the ball?
You wanna win?
Yeah. No. If I'm playing against you and you hit a ball and your ball goes in on my side of the court, do I have an incentive to call that ball in or out? Right? But the issue there was now what you can say is, look, if you screw me over, when your balls land in, I'm going to call them out. Right? And so we're playing a game where there's strategic interaction. We don't have a ball boy and umpire who can adjudicate what is in and what is out. And so we can either decide what we're going to do is we're going to cooperate, we're going to be honest, or we're going to cheat. If I cooperate and I always call your balls correctly, but you call my balls unfairly, I'm going to get screwed. Right? If you call my balls unfairly and I call your balls accurately, I'm going to get screwed and I'm more likely to lose the game. Right? But then all of a sudden we can say, well, okay, how can we set up a situation in which we cooperate? If you and I are just playing once, the insight here is going to be that there's always going to be an incentive for us to defect on each other because we're only playing once. However, if I say, Arturo, you and I are going to play every Tuesday before class at 8 o'clock in the morning, right? And if we want to have a really good game, I can say, you know what? Because we're going to be, if I care enough about those, if you said to me, look, Peter, if you cheat on me in the first time we played, I'm never playing with you again. If I care enough about playing with you in the future, I will actually cooperate and play nice. Does that make sense? Okay, good. Great.
So I understand, like, obviously you cooperate if the utility is greater than if you defect, but then, and I get the math, but once you get down to delta is greater than 1/5, what does that mean?
Right. So this delta is going to tell us how much do we care about the future.
Okay.
Does that make sense?
Yeah.
And so in the case of Arturo and I playing, let's say if I didn't care about the future tomorrow at all, or let's use the reverse. Let's say I cared very much about the future because I said, you know, Arturo is one of my students and I really enjoy having him in the class. And so like playing a game with him tomorrow is as valuable to me as playing a game today. That delta is going to be 1. And for like a really high level of delta, like the fact that I lose the opportunity to play with him in the future is going to really inform my decision to want to cooperate with him. However, if Arturo just went to the court and he was playing with some guy who was playing pickup tennis, and this guy's never going to see him at all, this guy's like, haha, I'm going to screw him. And I'm never going to see him again. So I don't really care about the fact that he will never want to play with me again in the future because I will never see him. Does that make sense? And does that answer your question? Yeah. Any other questions on this? And don't feel bad about having questions because I mean, like, I'm really taking like concepts from game theory that you might take like a couple of lectures to learn and condensing it down into a single lecture, right? And so don't feel at all bad if you have questions. Any other questions before we move on?
And we do get notes for this stuff.
You do have notes right here.
I
You should be
like,
taking notes.
I do. I just like clear ones.
You You should take clear notes. That's your, so I gave you guys notes for the first 2 lectures. In fact, what you can do is, so this group here is going to be typing up the notes from the previous class. Would you like to volunteer to do the notes in your group for this class? Okay, great. Good job. See, that's another example of game theory too, right? So like what happens is we set up a social contract where everybody wants to have good notes, right? And so with that, so the mechanism that we put in place is, okay, each group will get an opportunity to write the notes, right? And so if everybody cooperates, everybody's better off, right? But if one person chooses to defect, what they can say is, look, I'm just going to free ride and I'm going to get the great notes that somebody else did, but I'm not going to contribute any notes. But then if you defect, and then every subsequent group says, well, these guys defected, so like we're not going to cooperate at all, then the whole system unravels and everybody is worse off, right? Just because one group wanted to free ride. And so this is exactly the mechanism that we're trying to get at. And I'm going to get to your question in 1 second, Anna. And one of the reasons why I'm walking you guys through this by parameterizing this delta instead of saying delta is a half is you can look at what happens to cooperation as you vary the level of delta. Whereas if we put in a specific value of delta, let's say for tennis that delta is a half, but let's say for golf delta is like 0.8, right? Then we would have to go and solve this whole problem again and figure out exactly at what level would you want to cooperate. And so that's the strength of doing the parameterizations. The other part too is like once you get familiar with it, it's not very difficult. But a lot of times people have a conceptual difficulty with math because they think, oh, this is really hard. I can't do this. I want to see numbers. I need a calculator. And what I'm trying to do is to push you off of that crutch to let you know that you can do it. Anna and then the gentleman over here.
Do the notes have to be typed through share latex?
Yes. Yes. And you will get so much better at it as you type. What to do is you can use on the course website, I have posted the LaTeX files for the notes that I've given you. And so that's a way of like giving you a template for that. Okay. So I think, yes.
I think I'm kind of confused about how you set up the initial equation. I understand where you got the 4 and the 5
Yeah.
for the utilities, but after that, the 0, could you explain that? Like the difference?
Yes. So in this case, player one has chosen to cooperate in the first period. And then if player 2 cooperates in the first period, player 1 after that will continue to cooperate. But if player 2 defected in the first period, player 1 is going to defect in all subsequent periods. So this is like, if you don't like my picture today, I'm going to defriend you. Right? So where we get the zeros from is the following. If player 2 chose to defect in the first period, player 1 is going to choose to defect in the second period. And given that player 1 is going to choose to defect, the optimal strategy for player 2 is going to be to defect as well. Right? So given that player 2 has defected in the first period, player 1 is going to defect in the subsequent period. And given that player 1 is going to defect in the second period, then player 2 is an optimal strategy to defect. Because if player 1 said, oh my bad, I made a mistake in the first period, I defected, but like actually I want to cooperate now, then player 2 will actually get like a lower utility from doing that. And so that's where the 0 comes from. Does that make sense?
Yeah.
Okay.
Thank you.
And they play defection for every subsequent period too. Okay. So, and this part is clear here, right? Yeah.
So in this scenario, are there only 2 periods?
No, in this scenario, there's an infinite number of periods. And each one of these represents a different period, right? So this is period 1, 2, 3, 4, so on and so forth. Does that make sense? So this is today, this is tomorrow, this is what they have today. And so they're computing, so what the players are doing is they're saying, given that I am here today, where am I going to be in the future? Given the strategies and the actions. Any other questions? If not, let's go to a 3-minute break. If you need to use the bathroom or do something else, feel free to do that. The second part of the lecture is going to be a lot easier. We will have numbers. So for those who don't like numbers, we will have numbers. Okay. So let's take a 3-minute break and let's reconvene at 11:46.